Hey all, welcome back to my channel. So in today's channel we are going to discuss about system verilog concepts. Okay, so since today is Tuesday, I'm going to upload the system verilog concept. Okay, and on Thursday and Friday I'll be going to explain about verilog concepts. Right. So today, since we are going to uh, learn about system verilog concepts, we will see what is there in system verilog and why is this system verilog uh, existed instead, even though we are having like verilog. Okay, so in the previous session I have already told you why this system verilog existed even though there is verilog. Okay, so I'll link that in the description box. You can go and check it out there. I have already explained about the overview of verilog, like entire verilog, in just a short period of time. Okay, so you can go there and check it out. Now coming to system verilog, we can say that system verilog is the advanced version of verilog. Okay, just similarly. So when you come to the concept called advanced version, I think you already know what is advanced. Advanced version means the old version, whatever that is there in old version, the along with that you will be adding some more features for this particular thing. Is it or not? So similarly, in system verilog also all the verilog concepts will be present, and along with that, okay, you will be having many more advanced features. Like if you see here, you will see the like data types, arrays, procedural concepts, all you see in verilog also. In tasks and functions also you'll see. And when it comes to fork join, any fork join, none, these are advanced features. And then one of the important advanced feature is oops concept, and then constraints, randomization, interprocess synchronization, okay, assertions, functional and code coverage, okay, test bench development. So these are all the advanced features of system verilog, which makes it very useful for verification background in this particular front end of VLSI. Okay, so because of all these advanced features, this system verilog has become very versatile for verification. That is why we call the system verilog as both hardware description language and hardware verification language. Okay, what is meant by this verification? Actually, we have also done the verification in verilog also. If you see that whatever code that you are going to write within the test bench, that is verification. Is it or not? What you are going to do, actually, when it comes to verilog, you are going to write the design code, RTL code, and you are going to write the test bench code, and you are mapping both the, like you are connecting both the design and test bench with the help of DUT. Okay, instantiation, module instantiation, DUT instantiation, and then you are passing the values in your test bench, and those values are going to the RTL and they are being converted, and then you will be monitoring whether the design that you are designing, whether the code you have written doesn't contain any errors or not. So this is all the thing that is happening. Is it or not? So this is what the verification is. But we have never seen anyone calling that verilog is a HVL, hardware verification language. We call verilog as HDL, hardware description language. But when it comes to system verilog, it is the combination of HDL and HVL, nothing but hardware description language and hardware verification language. So we are particularly pointing out that system verilog is mainly designed for verification. Okay, whatever circuit you are going to design, you are verifying it with the help of system verilog, not with that of verilog. So why is this happening? Okay, I'll be telling it in the last in the last of this video. Okay, why this how we are telling that verilog is not efficient for verification, but system verilog is efficient for verification. So when coming to the introduction of system verilog, it was introduced in 2002 and was adapted to IEEE standard in 2005. Later it was merged in verilog standard in 2009. Okay, so it's a combination of both HDL and HVL. Okay, system verilog is a hardware description and verification language that extends the capabilities. That is what I said. It is extending the capabilities of verilog by adding new features. Okay, new features for hardware modeling and verification. right? So we can say that since we are not entirely changing the subject here. Along with the topics along with the concepts that are there in the verilog, we are extending it. So that is why it is called as extended version of verilog. Okay, so where are this extended version? Like extended version means we are taking some concepts from some other languages, and we are using this. We are extending the features of the system verilog. In that way, we have extended some of the capabilities from OpenVera in system verilog, and then there are many significant changes in verilog. Okay, like it is having many advanced features. I'm telling, right? What are those advanced features? One of the most advanced features is OOPS concept, okay, object oriented programming concept, and like functional coverage concepts, assertions. Okay, you haven't seen any of these things in verilog, right? So because of this advanced features, many companies have adopted system verilog as part of the verification medium. That is why, because as I already told you in the starting class of verilog itself, okay, almost 70% of the time is taken in the verification itself when you are designing any circuit. Why? Because basically I have already told this process, like after receiving the spec, okay, after RTL persons like RTL designer will be designing the code. Then if there are any bugs, again the cycle will be following. The verification engineer will be giving to the RTL engineer. Again, if there are any bugs, he will check it out, and again it will give. Again the verification engineer will be checking where the bugs are present, and then again it will be given to the RTL. So in this way the process. So because this since this verification is very important in designing some particular circuit, that is why it should be done in an efficient manner. So in verilog this efficiency is missing. Why this efficiency is missing? Because verilog features are limited. Okay, verilog is designed for RTL itself, like in order to design the code it is designed. But it when it comes to verification, we can say that verilog features are limited for verification. That means we can't actually do the verification in verilog. So that is why we need some other thing in order to improvise this verification, in order to speed up this verification. So that is why many companies actually, when there is no system verilog, what they use to do this, because system verilog doesn't have this oops concept and all. So that is why they used to customize this particular thing, like by using verilog they used to write the code, and by customizing solutions, like they used to take the oops concept from some other language, they used to work on it. Okay, but after system verilog has come into existence, okay, many of the companies have started using this system verilog itself. Clear? So hope you got an idea. So why SV over verilog? Okay, from starting I'm telling verilog is not used for HV verification system. Verilog is used for verilog. But why? What is the reason? Even though we are having these many concepts in verilog, okay, now you can come to know. Now whatever we have learnt in verilog, is it waste? No, actually, as I already told you, Verilog, system Verilog is the extended version of Verilog. Along with the concepts in Verilog, you are going to learn many more concepts and implement in your verification field. Okay. System Verilog is often used for design verification and coverage analysis, which you can't do with which you can't do with such efficiency using Verilog. You can write the test bench. You are writing the test bench in Verilog, but that is limited. Okay, that features are limited. So that is why when you are designing a simple combinational sequential circuit, it's fine with verilog. But when you are designing a complex circuits which consists of some 10 counters, 10 half adders, some full adders, okay, if you are designing such a complex circuits, what is happening? The verilog resources are limited to work on this particular complex circuits, which is why a system verilog came into existence. Okay, and one of the most important drawbacks of the verilog we are going to discuss now. What are the drawbacks, what are the limitations of verilog which led to the reason of existence of system verilog? Okay, so one of the important concepts is object oriented nature of system verilog. Okay, The object oriented nature means nothing but it is by using whatever you're going to write code, whatever you're going to write it in a test, means everything you'll be write it in the class based. Whereas in verilog, if you see, you are writing it on the module base. That is my third point. See, in verilog, whatever you're going to write, you are going to write it in a module based. But when it comes to system verilog, whatever you're going to write, you are writing it in a class based. And when it comes to modules are static in nature. Okay, that means static means they are rigid in nature. We can't automatically convert, we can't change it in the way we like it. Okay, but when it comes to object oriented nature, which is classes are dynamic in nature, which is why they can be changed in a whatever mode we like. We'll be seeing what is this change and all in the further sessions. Okay, like when we discuss about this oops concepts, we will be learning about all these things. But as of now, you just remember that modules are static in nature, so that is why we can't easily implement verification by using modules in the verilog. And when it comes to system verilog, it is object oriented nature, which is classes, which is we are using classes, and that is why it is used in order to verify, it is used in verification domain, we can say that. Okay, see, which may it is because of its object oriented nature, it is very powerful to verify corner cases of the logic. Okay, what is this corner cases of the logic, right? So here one is led to another, one concept is tied to another, and another concept is tied to, everything is interlinked in system verilog. Just like, okay, I'll explain this what are these corner cases of the logic in the next concept. Okay, so that is why, as I already told you, before system verilog many companies used to customize the solutions with the oops concept. Okay, and one of the disadvantages in verilog is, okay, one of the first limitation is, as I already told you, in verilog everything is module based, which is static in nature. Okay, and then in verilog you are having many in verilog you don't have the object oriented nature concept like oops concept. And then one another problem in verilog is race around condition. Okay, now you can have a doubt, ma'am, we have already discussed about race around condition in verilog, and you told that by using non-blocking assignments you can avoid the race around condition. Yes, when can we avoid it? When you are assigning it in, when you are assigning some same as like I am saying that when you are assigning the same variable for different same value to different variables, then you can avoid the race around condition in verilog by using non-blocking statements. It's fine, but there is another concept like, what is actually the race around condition means? Race around condition means two operations are done at same time in the same region. Okay, there comes the clash. Is it or not? So basically in verilog the main disadvantage is you are having only limited regions for execution. Is it or not? How many regions do you have in verilog? You are having four regions, four event regions like active, inactive, NBA, postponed. So whatever code you are writing in verilog, all the code that you have written in the verilog should be executed within these four regions. Is it or not? So for example, when you are writing two statements like dollar display and dollar write, now you already know that dollar display and dollar write, they both will be executed in the active region itself. And assign keyword, okay, assign continuous assignment, that is also executed in the active region itself. So when all these are done in active region only, then the system will get the clashes like which to execute first and which to execute next. So you may have that, does this execution makes a difference? Yes, of course it makes a difference. When it comes to verification, every single step execution makes a difference. Okay, so that is why we need many more regions apart from these four regions which are available in system verilog. So that is also one of the advantage of system verilog. Okay, in system verilog you are having total of 12 regions for the statements to be executed. Okay, instead of four regions that are there in verilog, along with those four regions you are having, you can say that 8 more regions extra in system verilog. Okay, and the another disadvantage in verilog is assertions. Okay, assertions is nothing but in order to verify the behavior of the design, you will be writing the code in order to verify the behavior, how your circuit is behaving when you are giving this particular input. Okay, right? So this is a this is very advanced in in system verilog. Okay, then then you may have that, can't we write these assertions in verilog? You can write the assertions. Okay, you can write the assertions in verilog. Inherently assertion based verification is not supported in verilog. Okay, but you can write some type of assertions in verilog, but these assertions that you are writing in verilog will make the code very complicated. Okay, you can't write it very easily in verilog, right? So in order to avoid this all, system verilog is having a very easy way of writing a assertion, easy way in order to check the behavior of your circuit. This is also one more advantage. Okay, these are some of the major advantages. And when coming to, let us see the difference between system verilog and verilog. So you already know that verilog is a hardware description language, system verilog is HDL as well as HVL. We have discussed every topic here, right? Verilog is used to structure and model electronic systems. Along with the structuring designing, this is also used for simulating testing the electronic systems. Okay, so verilog is module based, as I already told you, but system verilog is class based. Okay, verilog is influenced by C language, Fortran programming language. System verilog is based on verilog, VHDL, and CPP programming language. Okay, if you know verilog, these two are not probably most important. Okay, like even though you don't know like CPP and VHDL, also if you know the verilog, you can learn system verilog. I can say that. Okay, so for verilog you will be having the extension like .vr.vh, for system verilog .svr.svh. Okay, in verilog what are the two important data types that you will be learning? Wire and range. So in system verilog, along with this wire and range, you are having many more data types like enum, union, struct, string, class. So all these are various data types. Okay, it is based on hierarchy of modules. Okay, it is based on classes, nothing but the when you are using some modules, okay, you will be having parent module and submodule. The hierarchy is based on modules. Okay, whatever you write within the verilog, you should be writing within the modules, but in system verilog it will be based on classes. That means class, parent class, child class, okay, subclass. So all this way you'll be having everything in system verilog class based. Okay, and coming to advanced features of system verilog. So these are some of the advanced features of system verilog, like randomization, data type, synchronization, assertions, functional coverage, oops concept. So these are various features in system verilog. Okay, so now what is verification? Verification is nothing but you already know that, okay, is the process in order to ensure that the given hardware is working as expected. Is it or not? So that means when you are writing, make sure that the design is bug free by verifying it in all aspects and all possible scenarios. Now in the before I have already told you like corner cases. Yes, I am going to explain it in the last. Now we will see what is this. So in verilog, whenever you are going to write a test bench, actually what you will do, okay, see for example, this is my verilog half adder. Okay, this is my verilog half adder code. Now if you want to write the test bench for this particular half adder, okay, if you want to verify this half adder, what you will be doing, you will be passing the values from test bench. Okay, how you will be passing the values? You will be manually passing the values, is it or not? Okay, like some you will be passing like a equal to 1, b equal to 1. Okay, then after some two time units, hash 2, a equal to 1, b equal to 0. After hash 2, a equal to 0, b equal to 1. So what you will be doing here, you will be passing the values, is it or not? Like how you will be passing like hash 1, okay, a equal to 0, b equal to 1, right? After that hash 1, a equal to 1, b equal to 0, then again hash 1, a equal to 0, b equal to 0. Okay, hash 1, a equal to 1, b equal to 1. Okay, since this is a, like for example, if you consider this is the, in this way you are manually passing the values. If this is only of 2-bit, it is fine. Okay, for example, if you are thinking that this half adder is, or you are designing some counter or anything. Okay, for example, you are designing the mux. Okay, 2 by 1 mux. Now what will happen? It will be having two inputs, fine, and one output, fine. Okay, so since two inputs, you'll be having like combinations. Okay, based on the input selection lines, you'll be having combinations. So based on selections, you'll be writing, fine. For example, if you are having like 4 by 1, now what happens? You are having two selection inputs, fine. If you are designing 8 by 1, okay, four selection lines. Four selection means how many combinations will be coming? Okay, 2 power 4 combinations will be coming. 2 power 4 means 16 combinations. Now if you want to check all these 16 combinations, what you have to do? You have to write all these values for 16 number of times, or else by using some loops also you can write. But you should mention every thing manually here, like you have to write everything manually, you have to pass everything manually. Okay, for example, if you are designing some 32 by 1 mux, now is it possible? Like it is possible, but doesn't it take time? For example, if it is not 32 by 1, if it is some 2046 by 1 mux, then how many input selection lines you'll be having, how many possible values you need to send, right? Is it manually possible to send all these values? No. Okay, yes, did you get my point here? So but in order to design a circuit, you should test all the possible values, is it or not? Because even though there is, even though if the your system is not reacting for one value also, your system is bug, is it or not? Yes. So you have to check all these combinations manually in case of verilog. But what happens in system verilog is you don't need to check manually all these selections. You are using the randomization topic in system verilog, okay, which is the advanced version compared to that of random keyword in verilog. The random keyword you use in verilog is also used for randomization, but that is not very efficient compared to the randomization thing that you are using in the system verilog. Okay, so in this, in order to check all the corner cases, because even though one case is not checked, maybe that case can have the bug, and then your system will entirely can is not reacting to the way you want for that particular case only. Okay, so now what is the thing for verification? You have to check all the corner cases, like all the possible scenarios. Okay, for 2046 by 1 mux. Okay, if you are thinking of the scenarios, so for all those possible scenarios, your mux should act like a mux. Okay, it should give the output what you want, what you are expecting from it. Okay, so that is why in order to check it in a very efficient manner, we are going to use the system verilog. Because since verilog doesn't have these advanced features, so we can use system, we can use verification in verilog, we can do verification in verilog. But since of because of its limited nature, okay, we can't go for the advanced, we can't verify complex circuits by using the verilog language. Okay, in order to verify very complex designs, we only need system verilog. Okay, got my point? So this is about what is system verilog, introducing system verilog to you. In the tomorrow session we will be discussing about test bench architecture, right? If you like my explanation, consider subscribing my channel and hit on the notification bell also, and follow me on the LinkedIn, Quora, and Telegram channel also, where I'll be uploading notes. Okay, so that is all for today. Thank you.